So we learned these adrenergic blockers. These are the drugs which prevent binding of catecholamines to the receptors, that is alpha receptor as well as beta receptors. Uh, so catecholamines we learned that are adrenaline, noradrenaline, dopamine. So they produce negative chronotropic, negative inotropic, and vasodilation effect. We classified them alpha blockers, beta blockers. Then we have seen exclusively about alpha blockers, where we told they are widely used in treatment of prostate cancers. We concentrated here much. We concentrated much here. So we learned these psilocybin, tamsulosin are more prominent ones because they act at alpha 1A receptor than alpha 1B receptor. Alpha 1B receptor is present in blood vessels. Alpha 1A receptor is present mostly in the prostate cancer, prostate gland at the base of the urethra. So when we block, no, it gets relaxed. So all the symptoms which are present with benign prostate cancer are relieved. So if you have this benign prostate cancer, this is how it looks. Urine doesn't come uh, more freely. Now, what happens when it relaxes? It becomes normal, and you get it. So these are the drugs we have seen. Quinazoline drug we have seen. In that, prazosin, terazosin, doxazosin, all these we have seen. So these we all seen these cataract. Now, let us learn beta blocking actions. So for our convenience, you see, beta 1 is present in heart. So beta 2 is present in lungs. So when adrenaline or catecholamines, especially adrenaline, noradrenaline, when binds to when binds to uh, when it binds to these beta blockers, when it binds to beta blockers at the beta 2 receptor, sorry, when it binds to beta receptor, what happens? There is bronchodilation. That's why adrenergic drugs are used in treatment of asthma. The bronchioles were getting relaxed. Bronchioles were getting relaxed. Now here, what happens is that if you block at alpha beta 2 receptor, if you block at beta 2 receptor, there is a constriction of bronchioles, which is not necessary for us, right? Which is not necessary. It's unwanted effect. That's why there is no drug specific beta 2 blockers. Maybe there are non-specific drugs. The non-specific drugs, what happens? It can act at here as well as here. It can block, but we don't want this unwanted effect. Unwanted effects binding, blocking the action at the beta 2 receptor. So there is no specific beta 2 blockers. So it is advantage to have a drug which have specific beta 1 blocker. So let us see, this is the introduction. Beta 1 receptor is present in heart. We have only one heart. That's why you can remember in such fashion. Beta 2 receptors are present in lungs and bronchioles. We have two bronchites, two lungs. So you can remember in this fashion, So let us go to next class of drugs. So there is you can see that these drugs, as usual, we learned many times, they are structurally similar. These drugs are structurally similar to that of catecholamines. Uh, uh, Beta blockers are structurally similar to the beta agonists. These drugs are similar to that of beta agonist means nothing but catecholamines. Then one more drug, isoprenaline. If you watched previous video, which I have shared yesterday, then you can get some idea. Isoprenaline was the drug which was primarily used in the development of adrenergic blocking agents, in the development of adrenergic blocking agent. So we will see in the video coming another 10-15 minutes. See, these agents are competitive blockers. We also know this. Many times, blocking actions is mostly of competitive in nature. So these drugs, what happens is that when you prevent binding of beta 1 receptor, binding of non binding of catecholamines. Why we are telling specifically catecholamines? Because these are generated in our body. These are synthesized or produced. These are endogenous substances. So when you prevent that, what happens? Heart rate decreases. I used to tell many times, adrenergic receptor system activates whenever you are in fear, uh, stress. So whenever you feel fear, what happens? Your heart rate increases. If that is if you prevent this action, then antagonistic actions will be obtained. So catecholamine ring can be replaced by a variety of cyclic ring systems. These drugs has catecholamines, variety of ring system they have replaced. We will see it. Classification of drugs. Classification of drugs. Here classification, you can classify in this fashion. See, non-selective. Non-selective means these drugs can act at beta 1, at beta 1 as well as beta 2. It can act at beta 2. Even at the beta 2, it will act on. Both receptor it is acting. So unwanted side effects you are getting. So I told you in the previous slide, what happens if it interacts with beta 2? Because it prevents adrenaline, noradrenaline binding to the respiratory system. So it causes constriction of bronchioles. No need to constrict unwanted. This is unwanted effect. So this is a nowadays we are not using, but we can see it. Non-selective propranolol. It is the first drug. The person who discovered this propranolol was credited by Nobel Prize. He was given by Nobel Prize. That much important. Till those days, there was no specific because they were many people were dying because of adverse effect with bronchioles. So first one specific drug was this propranolol, nodalalol. All these drugs consist of the suffix ol, 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 pindolol, timolol, sotalol. There is a here. Remember that. Cartilol, carvedilol. See, there is different. Labetalol, labetalol. So these are the drugs which are non-selective. That means they can act at beta 1 as well as beta 2 receptor. Now, beta 1 selective drugs. Beta 1 selective drugs. These are very specific drugs. Nowadays, we are using widely these drugs because we don't want unwanted effects. So beta 1 selective. Acebutolol, this is the first drug from this family. Atenolol, bisoprolol, betoxolol. You can see it. All these have suffix volol, atenolol, metoprolol, esmolol, nebivolol, nebivolol. So these are beta 1 selective drugs. Now, some of the drugs you can see it. Now, you can see it here. Mixed blocking. Mixed blocking action at alpha receptor as well as beta receptor. These are mixed. So labetalol, carvedilol, labetalol and carvedilol. These are the mixed blocking drugs. Mixed blocking drugs at alpha receptor, even at alpha receptor. All these are concerning to beta receptor. Now this is the drugs which are at alpha and beta receptors. Yes. Yes, Priska, please.
Yes. So what the difference between the non-selective and the mixed blocking alpha beta?
What is difference between selective?
Non-selective and mixed blocking alpha and beta.
We will learn mixed alpha blocking agents will block at alpha receptor as well as beta 1. What happens when adrenaline binds to alpha receptor? It was causing contraction. Now, when it is blocking now if you block that, it causes vasodilation. So advantage. Hmm? So nowadays, labetalol, carvedilol usage has been increased, especially in congestive heart failure. We will learn, please. So mixed blocking action is also good. So adrenaline, when binds to alpha receptor, we told you just now, alpha 1A, alpha 1B. Now here, when it prevent that, dilation occurs. Now our USA road will become like thicker road. So vasodilation effect is there. That is the advantage of these drugs. But suppose if he has some prostate cancer and all it is also advantage, but they're not used in prostate cancers. That is the thing. Clear? Okay.
Yes, sir.
Let us see now. Next drugs. So one more way of classification, you can do it here. You can see here one more way of classification. Nowadays, this is why given is that even in pharmacology, you can see it. First generation, as usual, non-selective. Non-selective. So enhance alpha receptor mediate vasoconstriction activity. So non-selective drugs, some of the important future here with respect to blood vessels we are discussing. With respect to blood vessels in all these drugs, we will see it. So non-selective, as we told, all those drugs. Few examples we placed here: propranolol, timolol, nodelol, pindolol, sotalol. Then beta 1 selective. Beta 1 selective. That here you also should remember that selective means when you give high dose, even it blocks at uh, uh, beta 2 receptor also. Selectivity. So to what extent? At normal physiological dose, at pharmacological dose, these drugs are acting only at beta 1. If you increase the dose during a 1 second during experimentation, during the research, they done lot of activity, and they were able to found that they were able to find that it is yes, please. Yes, you can unmute yourself and talk. Ash.
Sir,
uh,
I wanted you to clarify on the non-selective. You said they have unwanted effects, bronchoconstriction in the
oh.
bronchioles. I don't know.
Non-selective will have bronchial effect. That means they doesn't differentiate between beta 1 and beta 2. I explained in previous slide. Non-selective means they have beta 1 and beta 2. For normal person, it doesn't cause any issue. Suppose if the patient is having both asthma plus hypertension, then issue starts. Already in asthma patient, bronchioles are constricted. Now, if you give these drugs, bronchioles are further constricted, but on heart rate is decreased, negative chronotropic, everything will be perfect. But here, bronchioles are constricted, patient will die immediately. We can start our WhatsApp group faster. That is the thing. Even for selective drugs, is here, beta-1 selective drugs. They are also effect mostly on the beta-1. To what extent? At normal pharmacological actions, it shows activity only at beta-1. If you increase the dose, it can also show effects at beta-2. That's why we kept here, these drugs are more effective at beta-1 than beta-2. And also you can see these drugs are less vasoconstrictors. Now, examples, clarified, please, Selena. Okay, Ash was asking, he also raised his hand.
I'm confused why for the first generation you're saying enhanced alpha receptor vasoconstriction. Like I don't understand why we're talking about that when we're doing beta blockers. So I don't understand that part.
They also, after doing research, they found this activity, enhanced alpha receptor mediator vasoconstriction. It is showing nowadays this classification they're also using. There is vasoconstriction, which is a which is a disadvantage for us. That is also we are not using these drugs nowadays more. Clear? Yeah, please.
Yes.
Okay. So what you're saying means that the action on the beta receptors is okay, but it's the alpha, it happens to act on alpha receptors that causes vasoconstriction.
Definitely, these are blockers, no? What is the effect of blockers? What is the effect of agonist? Agonist means it constrict. If it is blocker, even at alpha receptor, what it does? Constrict. So these drugs, though they are telling selective, but at high dose, it has these effects. And whatever we are telling, enhanced alpha receptor mediated vasoconstriction, it also has at normal physiological. About this, what we were discussing, that it at high dose, it also has beta-2 antagonistic activity. And these drugs are compared to these drugs, these are less vasoconstrictors. Less vasoconstrictor. If you're getting confused, you just remove this. But these are very important nowadays. Less vasoconstrictors. You can see it acebutolol, atenolol, bisoprolol. That means this also has little alpha receptor activity. But that's what we want to tell here. Acebutolol, atenolol, bisoprolol, metoprolol, and esmolol. Then third generation drugs, non-selective, that is between what is that, beta-1 and beta alpha and all those. Example is cortisol, carvedilol, labetalol. Then beta-1 selective vasodilator effects are there. Here you see vasodilator effects are there. These are more advantage. Previously we were thinking these are very good drugs. Very good drugs. Nowadays they are thinking that these drugs are very effective than these because of vasodilator. Here you see less vasodilator effect. Now here vasoconstriction effect is observed. Now these are vasodilators. So carvedilol, labetalol, nobibilol, betoxolol, they are using nowadays. So this is the classification. Any doubt, please? Okay. Now, first, let us discuss how these beta blockers came to market. Hmm? As I was telling this is the drug. Even in my previous video, you can see it. Isoprenaline. This is isoprenaline, which is very good drug. Let me draw the adrenaline, noradrenaline structure. Then you can understand very easily. This is adrenaline. Right. Okay. Now, these are adrenaline, which has catecholamine structure, which has catecholamine structure. Now, this is adrenaline, which cannot differentiate between alpha, sorry, we will write A for alpha and B for beta, which cannot differentiate, which can not differentiate. That means adrenaline can bind at alpha receptor as well as beta receptor. So, and it has amino group which gets metabolized. So to prevent this metabolism, they have placed this isopropyl group. Isopropyl group. On placing isopropyl group, now these drugs, here you can see the structure is similar to this adrenaline. We got this drug isoprenaline. Which is showing more activity at beta receptor. So this drug was showing more affinity towards beta receptor agonist. We got these blockers with the help of agonist. That's why we are bringing this information. Isoprenaline. Why we taken this drug as a lead molecule in the generation of beta blockers is that this drug showed more affinity towards beta receptor than at alpha receptor. What is the reason? What is the reason is that it is the isopropyl group which have shown this. So now this is the agonist. Now what they done is that in order to remove its binding to the receptor, they have changed to the naphthalene structure. So let us see first, instead of this, let us go in this direction. They have changed. Now you see, these are the hydroxyl groups which were binding to the receptor by hydrogen bonding interactions. Now, what they done is that isoprenaline is agonist. So instead of that, they changed to chlorine atoms. Now, hydrogen bonding interaction reduced. Then the compound name, what we got is dichloroisoprenaline. Now, what happened? It is full agonist. It became partial agonist. So some activity they observed. Then they even changed this chlorine. They removed this chlorine group and placed one more benzene ring, which we got naphthalene molecule, which we got, you see, the drug name is propranolol, which is also partial agonistic activity. So in order to avoid that, so what they done in next, we can see it. Let me clear again. So isoprenaline, we have taken as a lead molecule to generate beta blockers. Why we selected this than adrenaline, noradrenaline? Because this drug was showing more affinity towards beta receptors. So in order to make an agonist to antagonist, we need to place opposite functional groups. So these were forming hydrogen bonding. Now we placed with halogens, which doesn't form hydrogen bonding with the receptor. That's why this is a partial agonist. And also, now you can see it here. One more ring they placed. Still, we were getting propranolol, propranolol, which is partial agonistic activity. Now, let us go to next slide. Now, propranolol we taken. So here, what they done is that, what they done. So here, the group is attached at the second position. We discussed many times the nomenclature numbering system of naphthalene. So they removed this the side chain, whatever it is, with a small spacer, shifted to the beta to the first position. The small spacer X is usually an oxygen atom, and they instead of beta position, they shifted to the alpha position, or instead of second position, it shifted to alpha position. With a small spacer, that is nothing but with a OCH2 group they placed. See here how many carbon atoms were there? Let me clear, or let me take different color. You can see it. Here you can see how many carbon atoms? 1, 2. 2, it is like ethanol group. Here it is ethanol group, it is present. Now here you can see it. 1 carbon, 2nd carbon, and 3rd carbon. So here what is the name? Propyl alcohol, 2-propanol. Here it is ethanol, it is 2-propanol, or isopropanol group. So what is the spacer which we were telling X? What is the X which they have added is OCH2 group and shifted from beta position to alpha position. Then we got propranolol, which is antagonistic activity. Till here, we were getting the drugs of partial agonistic. Now we got an antagonist. Now this antagonist is a beta blocker. Now with beta blocker, it is not able to differentiate between beta 1, beta 2. That is different story. But we got this. The person who discovered this, propranolol, was given Nobel Prize. Nobel Prize. This is the way what they have discovered this propranolol. This is the drug design portion what we discussed. So this is one more time. I'm repeating. You see, the lead compound what we discussed helped us is isoprenaline, which is why we selected. I told you this was having more action towards beta receptor. Then they changed hydroxyl group to halogens. Now here also you can see it. All these were having only alcohol group. Ethanol group was present. Now here they changed to one more benzene ring. They replaced even halogens. Then we got propranolol. Then finally what they done is that they added some spacer, that is OCH2. They added the spacer and shifted from beta position to alpha position. So then we got this drug called as propranolol. So what is this group? aryloxy group, aryloxy or naphthoxy. If you want to specify specifically, if you want to tell, it is naphthyloxy. And here you can see it is propanol. See, it is propanol. You see, propanol and amine. Propanol, amine. Totally, it is propanol amine. What propanol? At which position hydroxyl group? At second position. At second position. Second position. 2-propanol amine group. And here also you can see isopropyl group similar to that of isoprenaline. So this is how these beta blockers come into market. Came into the market. So now you can see it. You see some of the important points on propranolol. See, what is that? Spacer, OCH2 introduced, which is nothing but what's the strategy in the drug design is chain extension. So chain length they have increased, that is called as chain extension, and vary substituent position. From beta position, which was in second position, we shifted to one position. That is the one more strategy. These are the two strategies which they have included to get a full antagonistic activity. Activity resulting in aryloxypropanolamine. We told you that in the previous slide I discussed this is aryloxy and this portion is propanolamine. Are more potent beta blockers than corresponding aryl ethanolamines. There are some of the drugs which also have ethanolamines. Ethanolamine, we will discuss. They are also more active. Substituent is positioned at one position of naphthalene. That is also what we told. Ether group, this ether group is important, and this is they have tried with many, with sulfur, with all this. This was the only successful. Is important, this hydrogen bonding and 10 to 20 times greater antagonistic activity. And this carbon is chiral, this carbon is chiral, this carbon is chiral. So S enantiomer is active. S enantiomer is active. But what is activity? See, activates active at both beta 1 and beta 2 adrenoreceptors. So this is the important points regarding propranolol. Next slide, we will see little information, SAR of these drugs. So SAR of these drugs, you see, first one, we will discuss from this end. Isopropyl group is very important. So this isopropyl group is responsible for binding preference to the beta receptor. This is the thing. Now, in most of the times, the amino group, what we are specifying here is secondary. And this amino group is essential for hydrogen bonding interactions. Then 2-propanol. See, this we discussed, this is a propanol group, propyl group, and hydroxyl group is there. That's why we call it as 2-propanol. This is also very important. Secondary alcohol. Now they try to remove this and place one more hydroxyl group. All those they have studied. This at second position is important. So secondary alcohol is also essential for hydrogen bonding interactions. There should not be any substituent on these two carbon atoms. So they try to place one more carbon and prevent the metabolism of all these, but they didn't show activity. So substitution let me clear. Substitution on these two carbons, these two, will lowers the activity. Then, as we discussed, this group is very important and it also forms hydrogen bonding. Now, regarding naphthalene, you can vary different heterocyclic rings. Different heterocyclic rings. Then we got many drugs. You can see it here. Here you see it is a what is that? Thiadiazole ring is present and morpholine ring is present instead of naphthalene, and it is showing the activity. Now, what is this group? You can see it is a propyl group, propanol, 2-propanol group. Now, here you can see it, pindalol. See the heterocyclic ring, what is present here is indole. So that's why the name pindalol. Now, here also you can see it, propanolamine group. Now, coming to this, you can see it here, ethanolamine groups are present. Ethanolamine group is present. And there is no any other heterocyclic ring. It is a benzene sulfonamide group. Benzene sulfonamide group is present, which is called sotalol. Which is widely used in arrhythmiasis, in treatment of arrhythmiasis. Timolol is used as antihypertensive and anti-glaucoma drug. It is very confusing why it acts in glaucoma. Just remember, that's all. These are timolol. Beta blockers are also used in glaucoma. Then one more drug you can see, nodelol, where naphthalene ring is present. One of the ring is saturated and 2-hydroxyl group is present. This is also a very good drug used in treatment of these all things. You can see it, heart pain, atrial fibrillation, arrhythmiasis. It can also use migraine,